Hi, my name is Asper Cisse. I'm going to be covering problem set 1, question 4, parts A, B, and C, pertaining to chapter 11, liquid solids and intermolecular forces. The question is the following. Isooctane, an 8-carbon branch hydrocarbon, is one of the compounds that is used to determine the octane rating of gasoline. Comparing isooctane to N-octane, the 8-carbon straight-chain hydrocarbon, answer the following questions. Be sure to fully explain your answers. A. Which of these compounds is likely to have a higher boiling point? B. Which of these compounds is likely to have a higher vapor pressure? C. Which of these compounds is likely to have a higher viscosity? Values are things that can be measured. The question is asking which has a higher boiling point, vapor pressure, and viscosity. Boiling point, vapor pressure, and viscosity are going to be the values that we're looking at. The variables are going to be the isooctane and N-octane molecular structure. Variables are things that differ from two things being compared, and because these are the same compound, the only thing that we can compare are the shapes of the compounds and the molecular structures. So the way we're going to answer this question is by first looking at the question and then asking what it's asking, what variables and values are present. 2, what do we know from our knowledge of intermolecular forces? 3, what intermolecular forces are going to be present? And then 4, we're going to apply everything that we've gathered to the question itself. So defining our terms, we're going to be looking at boiling point, vapor pressure, and viscosity. Boiling point is temperature when a substance begins to transition from liquid to gas. Vapor pressure is the tendency of a material to change into the gaseous state. Viscosity is how easily a liquid flows, so a higher viscosity is resistant to flow, while a lower viscosity flows easier. An intermolecular force is the attractive forces between molecules that is less strong than bonding forces. There are 4 types of intermolecular forces: dispersion forces, which are found in all molecules; dipole-dipole, which are found in polar molecules; hydrogen bonding, which are found in molecules where hydrogen is bonded to a fluorine, oxygen, or a nitrogen; and then ion dipole, which happens when there are ions and a dipole present in the compound. To answer this question, we also need to know what surface area is. The outer surface an area covers is surface area. The more surface area a compound has, the stronger the force is present. So a linear compound has more dispersion forces because molecules can better interact and touch each other. They can easily stack, so they hold on to each other a lot stronger, and they are more resistant to phase changes. So now we go back to the question and we identify what intermolecular forces are present, and we apply everything we know to answer the question. Looking at the two compounds, the makeup is the same. The only thing different is the structure. Isooctane has a more stacked structure, while N-octane has a more flat structure. Because the makeup is the same, we can look at both and detect the intermolecular forces for both. Both of them have dispersion forces because dispersion forces are present in all compounds. They don't have hydrogen bonding because the hydrogen atoms present are not bonded to fluorine, oxygen, and nitrogen. They don't have dipole-dipole forces because neither of them have a dipole. They're both non-polar. And they don't have ion dipole forces because they don't have a dipole. So looking at the structure, the N-octane has a flatter shape, so it has more surface area compared to the isooctane. We've deducted that more surface area equals stronger forces, so the N-octane has stronger dispersion forces. So looking back into the question, which of these compounds is likely to have a higher boiling point? The N-octane has a flatter shape, so it has more surface area compared to the isooctane. The N-octane will also stack better because of this flat shape, and it'll have more interaction between the molecules, so molecules will have a better hold on each other. This has the stronger intermolecular forces, so it'll be more resistant to phase changes compared to the isooctane, making the N-octane have a higher boiling point because it's likely to stay liquid longer. Part B is asking which of these compounds is likely to have higher vapor pressure. This is going to be the opposite of part A. Isooctane will have the higher vapor pressure because it's easier for it to turn into gas because it has less surface area, so it has a lower intermolecular force. It's less resistant to phase changes because molecules have less of a grasp on each other and will more likely break free and escape to the environment at less temperatures than the N-octane. Finally, part C is asking which of these compounds is likely to have a higher viscosity. The N-octane has more surface area, has a higher intermolecular force, and it'll stack in a more structured way because of its flat shape compared to the isooctane. So it'll hold on to each other better, resisting the ability to flow, making it have a higher viscosity compared to the isooctane. In conclusion, part A is going to be N-octane as the answer for the reasons listed. Part B is going to be isooctane, and part C is going to be N-octane. The answer to the question is found based on common rules for intermolecular forces with no math equations necessary.